last reflex I'm going to cover is the crossed extensor reflex. The crossed extensor reflex happens in conjunction with the flexor or withdrawal reflex. The reason why it happens is because, as you can imagine, if you are going to flex your knee and pull your foot up off the ground to avoid the tack you just stepped on, you're also going to have to balance yourself on the other leg so you don't come tumbling to the floor. So the crossed extensor reflex is exactly what it says it is. It is going to result in stimulating the extensor muscles on the other side of your body, or in the other lower limb. That's the crossed extensor reflex. So the interesting thing about this one is it uses the same sensory part of the arc as the flexor or withdrawal reflex because it is being stimulated by the same tack. So let's look at this image here. We see again, here is the foot. This is actually where the foot begins. This is where the foot ends. So these two pictures are the same leg. This is showing you when the stimulus happens, and this is showing you what the result is going to look like. Okay, so this is the same leg showing you the motion. On the opposite side, we see the other leg, on the contralateral leg, and this is where the leg may have been in your stride when you stepped on the tack, and this is how the leg is going to have to end up as a result of the cross extensor reflex, because it has to stand up and balance you on that leg while the other leg is off the ground trying to withdraw from the tack. So again, let's start with the sensory stimulus. The tack stimulates the nociceptors on the right foot, let's say, and that generates a nerve impulse in the sensory neuron. The sensory neuron nerve impulse travels along this blue line, that's the sensory neuron, into the spinal nerve, through the dorsal root ganglion, into the dorsal root of the spinal nerve, and into the dorsal horn of gray matter. Now, we saw already with the flexor or withdrawal reflex that it then synapsed with interneurons, one that came out the same section, like you see here, through the ventral horn of gray matter, through the ventral horn of the spinal cord, out the spinal cord, and then other synapses that ascended or descended to separate segments of the spinal cord so that they can continue to stimulate the whole muscle group, even though some of those innervations come from different segments of the spinal cord. That we saw already in the flexor withdrawal. Now, what we didn't see in the flexor withdrawal is that the interneurons that are synapsed by the sensory neuron in the flexor withdrawal reflex, some of them are going to cross the midline of the spinal cord and then exit the spinal cord on the opposite side, the contralateral ventral horn of gray matter, like you see here, and synapse with a motor neuron coming out of the ventral root, out of the spinal nerve, and to the contralateral quadricep muscles. Now, because different segments of the quadricep muscles or different extensors in the thigh are going to need innervations from different segments, we also have interneurons ascending and descending the spinal cord so that they can stimulate motor neurons from different divisions or different segments of the spinal cord. So now what we have is motor neurons being stimulated, causing contraction of the contralateral quadricep muscles and other knee extensors. So that way the body can balance itself on the opposite leg while the ipsilateral leg is being withdrawn from the harmful stimulus. This is not reciprocal innervation. This is its own separate reflex arc called the crossed extensor reflex arc. The reciprocal innervation for the crossed extensor would be inhibitory signals to the contralateral hamstring muscles. Contralateral from the flexor withdrawal, not contralateral from the crossed extensor. So the hamstring muscles on the same side of the contracting quadricep muscles would be inhibited for the reciprocal innervation of the crossed extensor. So the crossed extensor reflex is a contralateral polysynaptic intersegmental reflex arc because it happens on the opposite side of your body. It uses multiple synapses and it uses multiple segments of the spinal cord. So that's it for reflexes. We are going to finish up with there. We covered the reflex arc in general, the tendon reflex, the stretch reflex, the flexor or withdrawal reflex, and the crossed extensor reflex. Hopefully you were able to get an idea of what's going on by using the notes, this narration, and the images I've provided in the PowerPoint.